Hello, my name's Julian Edgar and I'm the author of this book, Modifying the Aerodynamics of Your Road Car. What I want to talk about in today's video is how you can organise the intake to your engine to make use of the aerodynamic pressure that's actually available. So think about it like this. You're driving down the road at 100 kilometres an hour, 60 miles an hour, and you put your hand out the window. Your hand gets pushed back. It's undergoing the pressure that the moving air is developing. So there is pressure available that can help you push air into your engine, but how much pressure is actually available? Well, there's good news and there's bad news. The bad news is, at normal road going speeds, there's not a lot of pressure. I did some quick calculations. At 130 kilometres an hour or 80 miles an hour, there's about 3.2 inches of water pressure available. Inches of water, it's a way of measuring very small pressures. It could either be in vacuum or in boost. In this case, we're talking about a positive pressure, a pressure above atmospheric. So how much is 3.2 inches of water in a practical way? Well, and I'll come to this in more detail in a minute, it's more than enough to make up for the pressure drop that occurs across most filters. So we all know that as the airflow passes through the engine intake filter, there is a reduction in flow. That reduction in flow can be directly measured, an approach I'll talk about in a moment. And when you measure most filters, they're typically in the range of 1 to 2 inches of water pressure drop at full load. So if you can pick up pressured air that's being pressured by your forward movement of the car, you can easily make up for the pressure drop that otherwise would be occurring across the air filter. And we all know how a dirty air filter does cause a loss of performance, so you can see there's a little bit there, but not a massive amount. But hey, it's free, you're not having to pay for anything, it's easy to organise, so why wouldn't you make the most of that forward pressure that can be developed? So, first thing, how do you actually measure it? Well, today I'm going to talk about some rules of thumb, but if you want to measure it, all you need is one of these. It's a Magnehelic gauge. They're now quite cheaply available on eBay, second hand. New, they're a bit more expensive, and you can simply run a hose from one port on the gauge to the point where you want to measure the pressure at the front of the car. And in the case of an air intake for an engine, you're obviously looking for that spot at the front of the car that has the greatest pressure when you are moving at a given speed. What if you don't have one of those gauges? And incidentally, I do suggest you buy one if you're interested in aerodynamics and interested in measuring actual pressures. I have a whole host of these gauges and I use them all the time. What if you don't have one though? What can you do to work out where the best spot is to take that air pressure into your engine? Well, let's have a look at this diagram I've drawn of a car. Like all the diagrams I seem to draw in these videos, it's pretty bad, but it still shows some important things. I want to start off by showing areas of low pressure. So where the air wraps around a curve, like here and like here, the pressures will be low. To put that into straightforward language, if you ran a hose to that part of the front of the car and the air was wrapping around over the top of that hose, it wouldn't be a positive pressure. In fact, it would be a negative pressure. It would mean less air went into your engine when the throttle was open. So those spots are not good to pick up air, and it's unlikely you're going to be picking up air from that curve anyway. But in the past, people have often picked up intake air for the engine from the wheel well, from behind the wheel, and there was talk that this was actually a high pressure area. Well, when you actually measure using a real gauge to see what's really going on, you'll find that the wheel well is typically an area of low pressure, so again, not a good spot to pick up air for your engine. What we want is what's called a stagnation area, a stagnation zone. And a stagnation zone is where the oncoming air is actually brought to a halt, and so velocity is traded for pressure. And if we look at where the air would be brought to a halt, we can see that it's typically that area there. Now most cars don't have a vertical front face as I've drawn here, but the radiator behind that grille typically is vertical or near vertical. In other words, if you can pick up air ahead of the radiator and adjacent to the radiator, you are almost certain to be picking up an area of high pressure. It doesn't even have to be an intake that faces forward. All it has to do is to connect to that volume that's in front of the radiator. And here I'm assuming, of course, that the radiator is actually sealed into place, and so the air can't just go around it. In front of the radiator is typically the highest pressure across the front of the car. It's also the easiest place to pick up air from, because normally you can actually get a hose into that particular volume, into that particular area. Of course, you could have a front-facing hose, you could have a bonnet scoop, a hood scoop, and that would achieve the same thing, but it's not actually going to be any better because the air in front of the radiator is being brought to a near halt. That is the area of highest pressure across the front of the car in nearly all cars. Now, the other half of the story, high pressure is great, but you also want that air to be cool. Cooler air has more oxygen means you can add more fuel and more air means bigger bangs, greater torque, greater power. So you want to make sure that that air that's flowing from in front of the radiator isn't heated. And typically it's not because the air's just come in through the grill and then it can pass through your intake hose. But always put a temperature probe in your new intake, perhaps when you're mocking it up out of just cheap plastic pipe or even convoluted tube as a mock-up, to make sure that that intake air temperature isn't high in pressure. So where does that leave us? In most cars, fitting a good high pressure cold air intake will improve performance, especially if the original equipment, the factory equipment, wasn't done very well in those areas. But you're not going to turn a car into a fire breathing monster by doing just these changes. On the other hand, you'll often get snappier throttle response because the lower intake air temperature means the ECU runs more advanced timing. It's not pulling timing off as much as it would normally. That gives you better throttle response, and typically you'll get a little bit more power, especially at speed. But remember, don't go away and start fitting this expecting it'll be like fitting a turbo or a new cam or porting the head. It won't be any of those things. But on the other hand, it's a relatively simple thing to do, and it does give results which you can certainly feel. It's covered in a lot more detail in the book, Modifying the Aerodynamics of Your Road Car, and as a bonus in the book I also cover measuring pressure drops right through the intake system. So you can see how much restriction the air filter is causing, you can see how much restriction even an airflow meter is causing, and so on, and those measurements can also be done with this magnehelic gauge. So it's actually a very useful gauge in terms of not only pure aerodynamics but also optimising intake air systems. Thank you.